And welcome to 90 Notes. This is a measuring activity, so let's get to work on our worksheet. First off, I'm just going to say we're given a couple triangles, and I'm just going to illustrate this one, triangle ABC, and we're also given these midpoints, X, Y, Z. So they're given as midpoints, so there's no constructing, it's all going to be measuring. Well, let's first talk about what we're measuring. We're looking at medians, and let's just define a median. And we'll say that a median is a segment drawn, let me see, from a vertex. Ooh, I like that. From a vertex to the, let me see, how about the midpoint? Yeah, of the opposite side. I like it. All right, that's a decent definition. It's a segment drawn from a vertex. So let's see, B is a vertex, and I'm going to go draw it to the midpoint Z. G is a vertex. I will draw it to the midpoint of X, the opposite side, right there. And A is a vertex. And of course, I'm going to draw to the midpoint of the opposite side BG, the midpoint's Y. And I asked you to do a bunch of measuring here, and everyone always asks, where's the C? Well, there's the C. We're going to say the C is the point of concurrency. It's where the three medians meet. And the point of concurrency, tongue twisted there, for where the three medians meet is known as the centroid. That's a vocabulary word you're going to need to know. So the centroid has a physical meaning. It's actually the point of balance. If this was a uniform object, and I just put my pencil on it right here. If this was stamped out of, let's say, a uniform piece of cold rolled steel, that would be the balance point right there. Now, I am going to say, I'm going to shade or darken these segments up a little bit because we're going to measure the pieces of the segments. What I mean by that, this very interesting relationship, I'm going to call this the red segment and the blue segment. The red from the vertex to the centroid, and the blue from the centroid to that midpoint of the opposite side. And yeah, we know the theory, so let's get out here and measure it. And I want you to take your Sammy straight edge. Well, now it's actually functioning as a ruler. And I want you to put that ruler on there. Let me see, best of my ability. Yeah, well, this one's coming out nice. It's looking like I'm measuring from here. Looks like I'm getting 24 for AC. And I'm going to use millimeters. Why? Because it's the easiest. And I'm getting 12. Well, let me see, wait, from A to Y, 36. Oh, this is too easy. 36 is the overall length. That's from over here. You're going to measure from A to Y. But then I want you to measure from C to Y. You can measure it like that, or you can reposition your little instrument right there. And no matter how I do that, I'm getting this as 12. Move the ruler out of the way. That makes sense. 24 plus 12 is 36. You know, if you're off by one, within a margin of error, it'd be all right. But this one is actually just perfect for illustrating our points. Because I'm going to say, what is the ratio of AC to AY? And I'm going to say that AC is 24. And of course, we're talking millimeters. And we're going to say that AY is 36. And you probably all noticed that, or heavens to Murgatroyd, that's going to simplify to the fraction 2/3, dividing out the 12s. Now, CY to AY. CY is, we measured 12, and AY we measured 36. Okay, and that very clearly simplifies to 1/3. And now let's look at it a different way. Let's take this measurement. Let's take AC, the red segment, or the red piece. See how this piece relates to the blue piece. Now, I said the blue, this this the blue piece, CY. And I'm going to say 24 to 12. Well, that's clearly going to be 2 to 1. So there's a lot of ways we can look at this. We can say the ratio of the long part, that is from the vertex to the centroid, is 2/3 of the entire median. Well, the ratio of the wee part, that is the short piece from the centroid to the midpoint, is exactly 1/3 of the entire median. Or I could say it this way. Look at the median itself. It's split into the two pieces. Though if this is 2/3 and this is 1/3, then this segment to this segment, 2 to 1. Or if I look at it, the reciprocal of that, the short side, the blue segment to this segment is going to be 1 to 2. CY is exactly 1/2 of AC. That is just, that's just too slick to be true. Okay, that one happened to come out perfectly. Well, what happens if our measurements don't? Now let's just suppose that I was measuring BC and I also got 24, but suppose I got 11 here and I got 35 here. Now you're going to get numbers like this that they just don't work out as beautiful as our first example. So let's look at BC. Let's just take 24 out of 35. Now we're not going to be able to simplify that. And I guess we could, well, you're not going to be able to simplify that, and you're certainly not going to get it down to 2/3 because it's not perfect. Our measurements aren't perfect. Our instruments aren't perfect. So you'll take your handy dandy calculator. Let's get it down here. Well, we can use that calculator, or we can even just use our little 4-banger right there. That's all we need. And let's take 24 and let's divide it by 35. And after all, that's what a fraction is. And we'll get that decimal. And I'm just going to write it down to 3 decimal places, and I'll put it right there. Now, of course, you all know that 2/3 would be 0.6 repeating, and, you know, close enough. Margin of error. Let's see what we get when we measure CZ. That's going to be 11 out of 35. And we'll take our calculator again. And where'd that calculator go? Right there. Let's clear it. And we're going to put it 11 divided by 35. And, well, we don't quite get 1/3. Yeah, off by a little. What we're experiencing is a difference between our experimental probability. Well, this is our experimental, and this is our theoretical happened to work out perfectly here. It should be exactly 1/3, but that's what we get with our actual measurements. Try one more calculation. And we'll say, how about the 24, that is this piece, to this piece? And of course, I'll say 24 to 11. And take out the handy dandy calculator, 24 divided by 11. And you see, again, we don't exactly get 2 to 1, but we're off by a little bit. So I just want you all to experience this, and we do a lot of theory, but let's make sure we know how to measure. And get this one measured up. Now you've got one more set. Well, you know, these measurements aren't the ones you're going to get, because I guess you have a different scale. I put it on your paper. So make sure you measure this yourselves. See what you come up with. See how close you get to 2/3, 1/3, and the 2 to 1 or 1 to 2 ratio.